Alright guys, this is part 3 of the video whereby I dismantled the blaster. So let's go ahead and take a look at it. If you missed the demonstration video, you can find the link under the description. So let's get started. Okay, first off, I just removed the battery. It's actually stored on inside here. So this is 1.5 mAh 65C bus and 65C constant, right? Yep. Okay, let me readjust the camera so that you can have a closer look. Alright, first off, the stock portion. So if I were to release it, okay, this will be exposed. In fact, this is where I kept the Arduino board. Okay, I make this so-called housing so that it's actually easier to slide in this this stock attachment over here, so it's very easy to slide it in and out. Alright. So for the stock attachment, I actually got rid of 2 screw posts for these 2 screws. It is still very stable because there are like 1, 2, 3, 4 screws to secure, and in fact there are some catches over here that secures. So if you want to, I'll show you some pictures of the internal, these 2 pieces whereby I get rid of in the picture. So in order for you to dismantle this, basically you need to take out 1, 2, 3, 4, 5, 6, and then over here there are actually 1, 2, 3, and 4, and you can dismantle this whole piece. Okay, I added this this metal piece over here, which is for the sling mount, so I can remove it if I want to. So again, let me just readjust the camera so that you can take a closer look at this thing over here. Okay, so this guy over here, actually I make it such that I can split it up. so that it's actually easier for me to do all the connections. So these are the connections whereby it connects to the Arduino board itself. So this is the Arduino board, right? So this is the second version. So at one glance you might think there is a lot of wires, but in fact it's actually a very simple circuit, which whereby later on I'll explain. Okay, so I can detach every one of them. You realize most of them will be coming in a pair like this, and in fact one of them actually connects to the ground, the other one is to a pin of the Arduino board, and that's basically for most cases, if not all. Okay, so over here you realize in fact a lot of them are actually the ground wires. So let me just remove all the pins. Okay, and then you have your Arduino board dismantle. So let's just take a closer look. So over here I actually cut off those pins that I'm not using. So please be very careful when you cut it off. Please wear eye protection, because you do not want these sharp pins to fly towards the direction of your eye. Please face it down and cut it off. I probably should have desoldered this portion because I don't use it at all. Because my board does come with these pins soldered in, so I just snip off those that I don't use, and then I'll just cut the rest to be a shorter length, and then it's actually pretty easy to solder. So over here, okay. So this is the board. So I can just slip it off. So if I don't have this housing, I find that it's very cumbersome to slot it into the stock attachment, because there are some friction with the wire and all. It's a bit messy. Alright, so with that out of the way, I can actually unscrew the plaster, and we can take a look. So let me just do the unscrewing. It might take a while. Okay, you can see that the two shells actually come off separate. Okay, so it's very clean. Okay, these wires are only for the OLED display and the button itself. Okay, this I'll keep. So for this guy over here, basically I cut a hole over here, and then a little bit of a modification over here so that this battery wire can go through it, and this jam door actually used as a sort of a clamp down for the wire itself. Okay, I actually reconnect back the Arduino board, because I want to just share some information with regards to the programming itself, how it works. Now, while writing a program and deciding how to do the controlling of how many darts to fire off, and how to ensure that this guy will always return to its position. Okay, after much programming, I realized there will be some situation whereby the pusher actually might end up at a sort of maybe at this position. Sometimes it happens. So by the time you reach this position, the darts had already been fired off, but I've stopped the pusher too soon, so it's not returned to the start point per se. So what I did was I actually wrote the program such that there is another subroutine whereby you always check whether the pusher is back to its position when it's supposed to. Now, after a certain threshold, which is in terms of milliseconds, if it detects it is supposed to be back but not back, then they'll kick in that procedure, and you will fire off the mechanism and make sure it push off slightly and make it return. For example, now the system is not on. I'm just trying to simulate that let's say the pusher end at this position at certain point of time. So if the system is actually active, it will check, and then it will make sure you fire off the subroutine and make it return. So for example, if I switch it on now, once the system is boot up, you actually fire off something to make it return. So you can see that no matter what happens, if they detect that the pusher is out when it's not supposed to, you fire off the module and ensure it's returned, and then stop everything. For example, if I were to just pull it out, it won't let it stay out. You'll make sure it goes back. Yeah. So just like to share this bit of information. If you are looking at the code, there's some part of it that actually handle this. So I'm gonna off the system again, and I'm yeah. So I'm gonna remove the battery. So again, like I say, most of the connection over here, although there are a lot of wires, but it's actually not that complex. So so in fact, each of the buttons over here, they are supposed to keep track of. In fact, they only consist of a ground wire and a signal wire. The signal wire actually connects to the Arduino itself, pin itself, and then of course the ground wire connects to the ground. So let's just take one for example, like this one over here. So you can see that it is just a brown and then a black. Basically connect to a button. Okay, one end to the Arduino pin, one end to the Arduino ground. So I'm going to dismantle everything again, and then we'll continue with the dismantling. Alright, let's continue with the dismantling. So let's get rid of the simple stuff first. This guy over here, this guy over here, and this guy over here. Okay, which is straightforward. Okay, so for the flywheel cage, so over here, this is the connection whereby I have a quick release such that I can actually replace the flywheel cage. So I've secured with the Velcro technique. Okay, so I can just remove it. Okay, so this is the Velcro itself. So this is the connector. Okay, so now we have our flywheel removed. So basically this is the canted flywheel from Worker. I did not use the high crash version because I have burst fire, so I think I'll not use the high crash version. So this is canted. Okay, so if you still have doubts whether if the canted flywheel does spin it down, or I think there's a very simple experiment you can do. This is that. Okay, so I draw an arrow. So if I were to just push it through, okay, so if I were to just push it through, you can clearly see that the arrow turns as it goes through, right? So again, okay, something like that. Right, now if you were to compare it with a non-canted one, for example, this guy is non-canted. Okay, if we were to just have the same thing, right, just push through, you just stay where it is, right? No spinning, no nothing. Okay, something like that. Does it make it more accurate? I can only say from experience, yes, it does make it slightly more accurate, in my opinion. Okay, so for the flywheel over here, again, I uses the Hellcat over here. Again, I attach the capacitor over here to reduce the electronic noise. so that you'll not affect the signal to the Arduino itself. Alright, it basically cleans the signal up much better. So let's carry on. So over here, this is the XSW kit. So if you were to notice, you realize this spacer that I use is actually much bigger. And if you use the XSW kit, you realize that this screw over here, after firing quite a number of darts, you realize it might come loose. So I guess in my final assembly, I will probably put something to make it more secure. But if now I'm just going to dismantle it. Okay, now why do I want a bigger space over here? Again, when I was testing the system itself, I realized sometimes this guy got flexed out in this manner. Okay, this manner, something like that. So you will not be able to extend all the way because it was able to sort of flex out. If I use the small spacer like this, there's a tendency that it might be flexing this way, and then it will just slip, and then it will not be able to extend enough. So I tried to put a piece here initially to see whether it helps, but it doesn't seem to help that much. So in the end, I decided, okay, the way to do it is of course to prevent it from flexing outwards, and one easy solution is of course increase the diameter of the spacer. So if I have the spacer of this diameter and place it here, it actually blocks the guy from sort of flexing out. Okay, there's no way he can flex out anymore because there's no room for him to flex out. So it's actually going to be pretty straight with this spacer over here. I'm going to remove this. So this is normal, nothing changed. Okay, so we'll keep this. So let's carry on. So I'm just going to remove this guy over here. I guess I will not remove this because there's actually nothing much to show over there. Alright, so let's carry on. Just going to remove the trigger. So over here, okay, basically this guy over here is basically a voltage sensor, which is this guy. All right, what I do is I desolder the two ends so that it can be a smaller profile, so that I can slot it into the butt stock. Okay, so I'm just going to detach this portion. Okay, so it's just an extension. So this is like how we do the voltmeter. We actually tap and rate, and I mean the positive and the negative of the battery itself, and then go through the voltage sensor, and then this actually goes to the Arduino itself. Okay, one to the ground and one to the analog pin. Alright, let's carry on. Okay, so what I'm going to do is I'm just going to try to get all this wire out first, so that it's less messy. Alright, so you can see that most of the wire comes in a pair, right? One I have a color code, and then of course the other one is black, is basically to connect to the ground. So let's take for example this guy is the one that tracks the trigger push. So if I were to remove it, and it come off, right? So basically just our switch that we use very often. Now it need not be a very big switch because there's no high current going through it. It's basically just a signal wire. Okay, and like I say, in fact, most of the buttons that we push that connects to the Arduino, we only need a pad, I mean, create it as such. Okay, one is to the Arduino pin, the other one to the Arduino ground. If you're able to do that, you basically can do this mod, right? So we'll carry on to dismantle the rest. So another example over here is the so-called the previous ref trigger. Now I use it as the mode, so I'm going to remove. So as you can see, again, it's just a simple switch. One to the Arduino pin, one to the Arduino ground. Okay, now I'll dismantle this. Again. Okay, so this is actually the power coming from the ESC. Alright, so I make a quick release so that I can have this unit by itself. Again, this is the one that counts the dot and to determine whether the pusher is out or in. Again, it's just one to the ground, one to the Arduino pin. Okay, so this is to check is the magazine out. Okay, get another container. So I only kept this piece over here because this is the only one I need to basically sort of push the this guy in, right? Okay. So again, it's just one to the Arduino pin, one to the ground. Okay, this one I actually went and insert the wire through the battery compartment and then come out from the other end so that it will not interfere with the pusher mechanism over here. Okay, so what is this all about? So basically this is the place whereby I house the ESC itself. So let's just screw it. Alright, so the switch is actually here. So the switch itself is basically to switch on the two ESC. So let me just remove this. Okay, so over here, so basically this is a 3D printed battery case. I got it from thingiverse, and then just do slight modification like having a hole over here, and then of course a hole over here to do the switch. I tried to look for it again, but for some reason I don't think it's there anymore. I think the creator have took it down for some reason. I don't know why, but anyway, also do a very slight modification is just to this over here to lower it so that it's easier to fit it in. Okay, so all this can be removed actually. Okay, if I were to push it, I think I'll do it offline. So now what we are left with is the 2 ESC, and then all the wiring over here we'll just remove out. And then of course just now the one that controls the magazine, I just slot it in here, and then so this one is the one that controls to detect the magazine is it in or out. Okay, so we're left with this shell here. Oh, by the way, this is a 180 motor cover that I got from Thingiverse as well. This is a fantastic cover, I find. Okay, it fits so nicely. I'll place the link to the creators. Sorry, I forgot the name of the creator, but it's really a nice cover, so you can check it out. In fact, I printed out for using a transparent filament, and then I have a light shining through it. It's very good looking. Okay, so this is the ESC itself. Okay, it might look a little bit complex, but let me just explain slightly what's going on over here. So this is what you receive if you buy the ESC itself. Okay, all right, so for this ESC, okay, you have the red and the black wire. This is for you to get the power supply for your LiPo battery. So there's a jumper setting over here. You can set it to LiPo battery, and then there's another jumper to set it to whether you want active braking or not. I set it to a forward braking for pusher and flywheel as well. So this is the power in, so that will make this two, yellow and blue, the power out. Alright, so this is where you attach to your flywheels or to your pusher DC motor. So this ESC comes with an on and off switch over here. Okay, so what I did was I cut off the on and off switch and then make it into a connection like this, small connection, so that then I can attach to the on and off switch that I prepared. Let's go over here. Okay, I have two ESC, so I need to in fact have two on and off switch, but I find this switch over here which have 4 legs. In fact, I now can have 2 circuits, and I can switch them both on, okay, without each of them interfering with one another, but now I can switch both on at the same time. Alright, so next comes with this wire over here. So what is this? The white one is basically the one you attach to your Arduino pin. It's for you to control the ESC, the speed of the ESC. And then you have a black and a red wire over here. Is the BEC, the battery emulator circuit. So in fact, I use one of the ESC to provide power for my Arduino. Okay, so that's why over here you realize that for the small wires over here, okay, I do have a pair of black and red. This is actually the one that is going to plug into the V-in and the ground of the Arduino. This is the one that supplies the power to the Arduino board. And then of course the green and the gray is actually, one of them is coming from the ESC to control the pusher. The other one is the one that controls the motor. And then to note, for both ESC, this one with the 3 wires, okay, the ground needs to be connected as well to the Arduino board. So what I did is, of course, I linked the ground together, but I only need one of the red wire to supply the Arduino with the power. Alright, and then both of the white, I will extend it using the green for one of them, and then the gray for the other ESC. So this will be connected to the Arduino pin, right? So in fact it's actually quite a simple circuit. So the main thing is basically this is connecting to the battery. So the battery will supply power to both ESC. So I'm connecting the battery to both ESC, and then I have another one coming from the power. This piece over here is just how we do the voltmeter, right? So we tap the power source so that we can read off the voltage. But for me, of course, I use the voltage sensor. So this actually connect to the voltage sensor and then to the Arduino itself. Alright, so this is the part. Alright, so now come this part, which is the OLED display over here. So all I need to do is now to disconnect it. Okay, so you can see that this is basically the part that house the so-called the OLED display. I just use the bolt and nut situation, and in fact I can also remove this out, and of course I can actually remove the button out as well. Okay, so before I start the modification, actually I told myself I want to achieve three things. First is to simplify the circuitry. I feel that the one I did for the Rapidstrike is just too tedious. So basically I don't want to do another one if it's so tedious. So I set out to reduce the complexity, which I think I am able to. And then the second one is I want to know how to do the OLED display, which I try out and it's quite alright. And the last one is I want to know more about 3D printing and basically do some basic printing and basic modeling. So I have zero knowledge on 3D printing, so I'm quite happy with my result. So in fact this is the one that I model myself. This is my first step. So and I'm quite happy with the printout as well. And I was able to just download some of the stuff from Thingiverse, which is great, and print them out and make use of. So kudos to those who actually spend the time to model all those wonderful 3D parts for the community. Yeah, so all these files actually can be found under the my repository directory itself. So I'm going to keep this. So now what we left with is basically the empty shell. So again, when I start off the modification process, I wanted something that I will require very little shell modification if possible, because for myself I have a lot of time constraint at my site, so I need to do modification at a very slow pace and then doing something part by part. So in fact for this guy over here, I only need to cut a hole here, and then some basic cleaning of a shelf or things like such, and nothing much. And for this side is even less. I just need a small hole over here, a small slit over here. Yeah, so so this is the dismantling of the Stryfe that I built. For the next part, I really want to come up with the circuit diagram, because I think I probably did not explain very well just now when I dismantle all the circuit, and I believe the diagram will help a lot. So for the next part of video, I really hope that I can come up with a circuit and tell you guys how I plan and how I figure things out. And I'm Tungsten, so thanks for watching. Hope you enjoyed the dismantle video. And now I have to put it back. Yeah, so thanks for watching. Bye.